Welcome to this tutorial and also welcome to my channel. As you can see, I'm trying to always keep updated the channel by new tutorials every week or sometimes every week twice. And in this tutorial, I'm going to talk about the advantages that you can get from the symmetry boundaries. I didn't have time to talk about the symmetry boundaries, and I think it's a good idea to look at the application of the symmetry boundaries within the electromagnetic simulator. In this, as always, I'm going to show you the advantages of that using a very simple solution. And in this case, I'm going to use a very simple transformer that is look like this. And this transformer, as you can see, there are symmetries on that, and you can actually use that and reduce the amount of computational resources that you need to calculate that by 8 in this case. So this is very important that you learn how and when you should use the symmetry boundaries in your designs. Sometimes you have a very complicated designs that you would very enjoy reducing the time or the complexity of the design by cutting this design to the parts that are symmetric, and then just calculate the parts, one part, and get the result for everyone. So as I said, the complete geometry of the transformer that we are going to work on is like this. And what we are going to simulate is the symmetrical model of that, like this. And before, I've done some simulations for half of the model. You can actually go back and check out those simulations as well. But in this case, I'm going to use the symmetry boundaries, which is a bit different than what I've done before. So let's go ahead and start our modeling as always, and then in the second tutorial you will see how to solve the general model, and then we will work on the symmetric model and then solve that as well, and then we'll compare the results and see how much we lost in terms of accuracy and how much we gain in terms of speed and simplicity of the model. Okay, first thing I want to make sure everyone is on the same page is the most important parts are on the Maxwell 3D. Go and check out that the solution type is magnetic and magnetostatic. So that's the first thing you want to do. The second thing that you want to do is you want to click on the modeler, and then you go down to the units and make sure that the units is selected to be millimeters. If it's not the case, change it to the millimeters, since I'm going to use the millimeters in this tutorial. First thing that we want to do is we want to make a region that in that region we are going to do our simulation. So I'm gonna create using the box. I'm going to create the region. I'm gonna put for the value, the absolute values of x, y, z of the very first point of the box. I'm gonna put -75 for all the values: x -75, y -75, and z -75 millimeters. I'm pressing enter to go to the dx, dy, dz, and for all of those values I'm gonna put 150 millimeters. So as you can guess, the box is gonna be a symmetric box, and the center of the basically the map is going to be the center of the box as well. Okay, I'm pressing OK on that, and on the attribute tab I'm going to double click on the name property and change it to a region. And I want to also make sure that the region is displayed as a waveframe, and when I press OK, you will see that this region is going to be like this. So this is where we do all our simulation. I want to just make sure that you can see how this region is created. And then what you want to do is you want to click on that and click on the eye icon, and then make sure that the region is basically not visible. It looks like that I already had a region, so let me get rid of the region that I had before. And so I'm gonna delete the region that I had before, and also I want to make sure that the region is um, defined not as a ferrite but as a vacuum. So you basically right click and assign a material on that and make sure that you're selecting vacuum for that, and so then press OK for this. So you have vacuum for the region. So now the default, as you can see here, the default materials is ferrite, so that's going to be the material that we are going to use for our core. So let's go ahead and select the core. So in the modeler, let's make sure that the grid plane is on YZ. Okay, and now what we want to do is we want to uh, basically change this to be able to see the grid. There we go. So now you can see our plane. So now we are going to actually have our stuff here. So in the draw, select the rectangle and start the points. So the very first point of this rectangle is going to be 5 millimeter. The Y is going to be -25, and the Z is going to be -20. Press enter, and for the dx we have 0, for dy we have 50, and for the dz we have 40. Press OK, and we will call this core, and probably we are going to have some color for that. So let's call it core. And we are good with that. Okay. Now I'm gonna zoom out a bit to be able to see more. And now what I'm gonna do is I'm gonna go and select the rectangle again, and this time I'm gonna put 5, -15 and 10. 5, -15 and 10 for the values, and for the dx, dy and dz I'm gonna put 0, 10 and -20. Okay, so press OK on that and call that the slot for or the hole that you want to have. Okay, and that's it. So you just press OK, and there we go, you got this. So now you want to duplicate that, so you can use the mirror to just mirror it on the other side, since everything is going to be symmetric at the end of the day. So you select it and you go to the edit, and I'm going to use the menu here, and over there you select duplicate, and inside the duplicate you want to select the duplicate as a mirror. So you just do this, and for the point that you want to press, you basically say the mirror is going to be on 0, 0, 0, so that's the reference point for the mirror, and the amount of that is going to be 0, but in dy we want to have 1, and dz is going to be 0, so that's how it's going to get mirrored. So we just accept that and press OK. Okay. Now, one thing we want to do is we want to make this to be basically we want to remove these two parts and make a hole from this surface. Note that here we are actually using the different technique for creating this um, uh, simple transformer. So in this case, instead of using the boxes, I'm using the sheets, and then I will use a sweep to create what I'm looking for. So go on select all these three and go on the subtract, and on the subtract make sure that the tool part is going to be the hole 1 and hole 2, and the bulk part is going to be, the blank part is going to be the core. Okay, press OK, and there we go. You have the 2D of the core. Now the only thing we have to do is to just sweep it. So you just select the coil and start sweeping it. If I can remember where was this sweep icon, that would be helpful, but I can't find it at this time. So probably we're gonna go through the old method of draw and then sweep. So then just go to draw, and then you go under this to sweep, and then you select the sweep along a vector that we know. And over here you just put the center, so 0, y0 and z0 for the xyz, and the amount of sweep is going to be -10 on the dx part, so -10 and nothing else to the others. So that should be okay. Press OK. It will ask you if you need to have a draft angle, and you say no to that, and you press OK. Now you have the core, and the rest of the stuff is fine. Okay, now you can't see the sweep right now, but if I do this, you can see it. There we go. That's what you got. Okay, perfect. Now what we want to do is at this time is to create the coil. So to do that, we want to have two coils that basically are on the same column, and these two coils are going to basically be the secondary and the primary. So first of all, we want to change the material to the copper. So just select copper here and press OK. And now what you want to do is you want to create our boxes. So in this case, I'm going to use a box here, and for the x value we can put the -9 and -9 for the y value, and for the z value you want to put the same -9. Press enter on that, and for the dx and dy and dz we have 18, 18 and 18. So that would be the same for all of them. So there we go. Press OK. So that's what we have, and instead of box 1 we can call it coil in. Okay, and we can assume that this coil in is gonna be this color, so we can change the color and we can press OK. Can actually make it a bit reddish, but there we go. So now that's the first one. So now what we can do is we can actually reduce, we can create another box, and we can subtract the core of this box and create kind of a coil by subtracting another box in the middle of that. So what we do is you just go and create another box, and I'm going to give you the numbers for that. -6, -6 and -9, -6, -6 and -9, and for dx, dy and dz we have 12, 12 and 18. 12, 12 and 18. Okay, so that way you have another box that is going to be subtracting the coil 1 in, coil in S, meaning subtract that. So I'm pressing OK on that. And now the only thing we need to do is to subtract these two from each other. So we don't have anything to do with the coil. So basically what we do is we select this, and you can actually press and hold the control key, and you can select both of them, and you go and select the subtract tool and make sure that in the subtract tool the blank part is going to be the coil, and the tool part is going to be the coil in subtract. Okay, and now you just press OK, and there we go. As you can see, we have here the subtraction that being done. Perfect. Okay, now we need another coil for the secondary, so let's do that. You can call it coil out. So what we do is we just create another box. It's basically the same. Actually, now in this case, I'm going to use the rectangle. So I'm going to use the rectangle and say for the x value, I'm going to use the value 0. For y, I'm going to use 10. And for z, I'm going to put minus 9. For dx, dy, and dz, put 0, 4, and 18. Okay, so 0, 4, and 18. And press OK on that. And this would be the coil out. Sorry. Coil out. So these are the two different ways that you can actually create these things. Let's put a color for this. Add. Okay. Sure. So now what I've done is I have here a rectangular sort of a thing. So now I'm gonna just create a sweeping path for that. So with that, we can actually sweep it around our main basically core. So one thing you can do is you just go and if we are on the same plane, by the way. Okay, now to do that you have to create lines, and with the line you make a path, and then with the path you can sweep it around this path. So what I'm going to do is I'm going to just first select the line, and then I want to make 5 points on this line very randomly, like this. Okay, and then right click and say done, and then I want to call this thing the path. Click OK. And then when I create this like that, I just go here and start putting the values. Makes more sense for me this way. So okay, so put the values. The first one is 10, 10, 9. 10, 10, 9. The second one is gonna be minus 10, 10, 9. And now when you do that, now the very first one is the same, the second point that we put. So the part 2 is going to be minus 10, minus 10, and 9. Okay, and then over here we have 10, minus 10, 9. Sorry, that is not minus 10. Okay, and over here we have 10, 10, 9 again. Alright, so that would be what we need. There is another extra line that is not necessary. I'm just gonna delete that if I can. So delete endpoint. There we go. So now we have all these lines. Let me just go on the top and you can see it better. You can see that? So this is the path. If I select the line, you can see that the path. This is the path. This part is the path. So if I uncheck it and check it, you can see it. Okay, so now what I'm gonna do is I'm gonna just sweep this along this path. Very simple. So select the part that you want to sweep. So this is the part, and by the way, if you guys had this problem that when you create this path, you ended up having a sheet, you just need to go into the modeler and then say delete the last basically delete the last what was it, operation. So right now you don't have it here, delete the last operation, but in case you this path, the closed path, turn into a face, you just go to the modeler and say basically delete the last operation. Okay, so then you will have the same thing that I have here. Okay, so now what I'm gonna do is I'm gonna go and select the coil and do a sweep. So select the coil, let me go in here, select the coil and then select the path that you want to do the sweep around it, and then you go to the modeler and you go to the draw, and then you go to the sweep, and then you say sweep along the path, and there is going to be no draft angle or no twist, and then just press OK, and there we go, you got it very easily. So that is what we have. Let me just make it zoom out. There we go. Okay, so that's what we get from that. You can see there are two coils, one of them called coil in, the other one is called coil out, which is this primary and the secondary of this transformer. Okay, now what we're gonna do is we wanna create terminals for this coil and start running a simulation on that. So that would be the subject of the next tutorial.